this is me. Today we're going to talk about quantum entanglement. And first, there's a few things I'm going to try to explain before we actually explain the main thing, because you need some context here. So, I'm going to assume you have an interest in science, and I'm going to heavily encourage that you take notes while I explain this, because, this is a summary. So if you write everything down, then you can read it later and put it together in your own head. But in the next, 5 minutes, whatever this is going to be, I can't guarantee you're going to have a full understanding. You're going to have to write it down, read it, go over it, think it over. Firstly, you need to understand that time is not universal. It's relative to the observer. This is called relativity. So different observers can disagree about whether two events happened at the same time. Information travels at the speed of light. I'm assuming you know that. So this causes information from an event to reach different observers at different points. So I just want to make sure you're getting that. Time is relative to the observer. Two observers can disagree about whether two events happened at the same time. Information travels at the speed of light. This causes information from an event to reach different observers at different points. I have a visual that I couldn't really draw. I'm too lazy. But just picture this. So if you and two other people are equidistant from each other, such that you form an equilateral triangle. Just imagine that. You can draw it if you want, an equilateral triangle of people. And let's say the two people you're looking at, you're equidistant from them, and they each flip a coin. From your perspective, they would both flip the coin simultaneously. Since they're equidistant from you, you'd see 1, 2, 3, boom, simultaneous. They both flip it. Following? However, let's say we take the perspective of one of those two people. Let's say they're looking at each other. So they'd have the coin in front of them, and they'd be seeing the other person with the coin far away. Let's say they both flipped it. So if the coin's right in front of them, they'll see that pretty quickly. But actually, while the other person flips, remember, from your original perspective, they flipped at the same time. If one of the flippers is looking at the other flipper, light from them doing that will take time to reach their eyes. So they'll actually see a minute difference. It'll seem as if they flipped their coin first, and then that happened afterwards. But different observers can be right when they disagree. Each observer is correct in their own frame of reference because the information from the events reaches them at different points. So to understand that observers can disagree about when things happened, because the light from those events takes different amounts of time to reach different observers. I hope that makes sense. Okay, I hope you have that. So second big point that I just want to mention is that you have to understand that physics describes what outcomes measurements of reality can produce, not hidden properties that exist in reality prior to measurement. So the laws of physics describe what outcomes we'll get from measurements of reality, but it doesn't necessarily describe reality itself, the hidden properties that exist in reality before the measurement. That's very important to understand. So if you have those two things and you understand them, we can move into the main point, which is quantum entanglement. And to make things simpler, I'm going to be using an analogy that captures the central structure. So there might be some nuance lost, but I believe that this analogy captures the essence and that you'll understand it. So let's keep that coin thing. Two people have a coin. And those two people, they cannot communicate or influence each other at all. That's very important. So when they each flip the coin independently, they either get heads or tails. And we must agree that before they flip the coin is not in the heads or tails state. The outcome of the flip does not reveal the state, it creates it. So the flip doesn't reveal what state the coin is in. The flip creates the state of heads or tails. The outcome is not a predetermined property of the coins. It is a result of the flips. The important thing about entanglement part here is that when the two people do communicate and compare the outcomes of their flips, once they've both flipped, their outcomes will be opposite. One will have heads and one will have tails. That's what the guarantee is, that the coins will be opposed. One will be heads, one will be tails. And so I just want to stop you before you go down a rabbit hole. You think, oh, one of them flipped first, and that influenced the other coin to know which result to have. Like, let's say one flipped heads. Oh, okay, so the other coin knew immediately to do tails. But that would require instantaneous communication, and that goes against the laws of physics. You have to remember it's relative. That time is local. There's no universal first or order. It's relative to the observer. I like to say that each observer lives in their own slice of a larger reality, and the two slices don't influence each other until they compare measurements. So the greater reality ruled that the coins must oppose. Independently, they're still 50-50, but overall, when they compare, they will match. Their outcomes must be opposed because of the laws of conservation. So you'll know in classical physics, quantities like momentum and energy are conserved. When you took physics in high school, you'll know like the forces, the momentum, the energy, it all comes to zero, right? It all has to be balanced. That's how the reality works. So it's similar with quantum mechanics, except that each coin just by themselves do not have predetermined values. The values are created by the flip. What is predetermined is the relationship between the outcomes, not the outcomes themselves. What's fixed in advance is that the outcomes of their flips will sum to net zero. They'll like heads, tails, it opposes. But it's not fixed in advance whether each coin ends up in which state. The one larger reality is predetermined, they will oppose. But individually, each flipper, it is not predetermined which state they will get. It is just predetermined that when they compare, when the two slices add up to a whole, they will be opposed. I really hope that helped you, because that's the essence of quantum entanglement. Thank you. Okay, I had to film an outro. So basically, that was quantum entanglement. So there's just a few things. First of all, I am not entirely sure how to turn on comments, but what I did do was I created an email. So if you watch this video and you're still confused and you are really interested and you want to contact me, I put it down in the description, legendaryquestions at gmail.com. So you can email me. I promise I'll do my best to get back to you. As far as I know, I've never done something like this before, but I know that was rushed. This is the very peak of quantum mechanics, and it can't be summarized in. I'm still editing this. That was 7 minutes. I'm glad to be back, and I hope to post more, but you never know. Certain editing software is just not fun. It takes a long time to edit these.